Hello everyone. So let's start with the string instructions of 8086 microprocessor. So in this lecture, we will learn about the string instructions. String instructions actually, as the name suggests, the word string, ये it means धागा. ठीक है ना, कोई धागा है. Suppose we have a string of beads. String of beads means कि जो हम ये कहते हैं एक तरह से माला जो आपकी होती है, आपने कई उसमें बीट्स यानी कि कई मोती आपने पिरोए होते हैं एंड दे ऑल आर कनेक्टेड टू वन स्ट्रिंग. ओके, दैट मीन्स नाउ यू कैन नॉट लूजली you cannot just take it one bead from this particular string. उसके लिए आपको धागे को तोड़ना पड़ेगा. So all beads are connected through one string. So that is what string instruction means here. Now let's see what happens. In case of string instructions, normally these instructions are similar to your data transfer instructions, but here what will going to be happen, instead of taking one data at a time, you have to actually store, or you have to actually work with all the data. Okay, all the data means a sequence of data you will collect. Okay, and then you will work accordingly whatever the instruction is given. So let's see what the instructions are first of all, then I will tell you ki how many data is required. Let's see. Suppose we have an instruction like move s, move sb, move sw. That means move s means it clearly indicates move the string. If it is written move string or move string, b means byte. Okay, move string byte, move string word. Okay, that means whether you have to take 8-bit or you have to take a 16-bit data, that completely depends on whether you are using SB or SW. In case of 8-bit, we will use move SB, that is move string byte. In case of 16-bit data, we will use move SW, that is move string word. Okay. Now, whatever instruction that you are giving, okay, according to that, 8-bit or 16-bit data from the memory location which is addressed by SI register, it will move to the memory location which is addressed by DI register. This is by default. Now what will going to be happen? Suppose this complete string is there and it contains the 8-bit data. Okay, then it is definitely, it will be written here that from which memory location till which memory location you will actually collect the data. So that is called a number of data which will move in case of string instructions. So either it will be an 8-bit or 16-bit data from the memory locations. Okay, remember this S is given here. There may be a possible that in case of string they can use only one also. Okay, because there is no such limitation of that. But remember कि आपको कौन से वाले डाटा को मूव कराना है. द data whose address is given in the SI register to the you have to take the you have to move that data to the one where the this address is given to DI register. Okay, now let's see. Next is CMPS and CMPSB and CMPSW. Now again it means compare string complete byte and compare string word. Okay, so again it will give a number of data. Okay, suppose the address is 2000, so they will mention it that from 2000 till 2004. So how many number of data will be there? 2000, 2001, 2002, 2003 and 2004. Total five addresses are there from where you have to pick the data. Okay, so what you will do here, you will compare the content of the memory locations which are addressed by DI register here with the content of the memory location which is addressed by SI register. That means the address is saved in the DI register and in the SI register, and you will compare the contents of those memory locations. Okay, next is SCAS, SCSB and SCSW. That means scan string byte and scan string word. Okay, now here what you will do, you will do the scanning of that. That means you will compare the content of the accumulator with the content of the memory location which is addressed by DI register in the extra segment register. Okay, that means extra segment, the memory location that we have, it is in extra segment, and you have to compare that content from the content of the memory location which is addressed in DI register. Okay, remember this. Now we have load. Load S, load SB and load SW. That means load string, load string byte, and load string word. Okay, again what you will do, you will load. We know what load and what store means. Load means you are giving it to a particular register from the memory, and store means from a particular register you will store that into the memory locations. Okay, so in case of load means we will load either 8-bit or 16-bit, that depends on the instruction given, data from the memory location which is addressed by SI register into AL or AX register. Now why AL and AX is written here? AL means if you are using 8-bit, then you will save it in the AL register, and similarly if you are using 16-bit, then you will save it in the complete AX register, which means AL and AH both. Okay, now similarly let's see what STOS, STOB and STOW means. Here it means that store 8-bit, store 16-bit data from AL or AX register in the memory location which is addressed by DI register. So that means they both are just opposite to each other. They both are similar, but in one you are loading the data and the other you are storing the data. Okay, have you got it? So let's see next. Next instructions are repeat. The first is repeat. Now repeat means you have to keep on repeating the given instruction, whatever the instruction is, until the value of the counter register becomes 0. As I told you earlier also, that it completely depends when you are using some kind of loop, or when you have to repeat a particular instruction. Then what you will do, you will give a particular number to the CX register. Suppose the CX register is filled with 4, that means 4 times that loop will go, or 4 times you will repeat the particular instruction, and you will keep on repeating after every repetition. That means as soon as the instruction is executed, the value of CX is decremented by 1, that means it becomes 3. Again you will repeat the same instruction. Again after execution, CX register will become 2. Keep on repeating the particular instruction, and you have to just keep on repeating till the value of CX register becomes 0. So this is what repeat means. Now comes, there are some special instructions like REPE and REPZ. REPE means repeat if equals to, repeat if 0. That means if two values are equals to each other, the subtraction of that will give a 0 result. Okay, you know that. So equals to and 0 are one and the same thing. So you have to keep on repeating a particular instruction till CX becomes 0 and 0 flag is high. These two CX register should not be equals to 0, sorry, and 0 flag is high. That means it should fulfill these two conditions. Okay, remember CX register is not equals to 0, but 0 flag is high, so you have to repeat, keep on repeating till then only. Now repeat if not equals to, or repeat if not 0. Here you will keep on repeating the given instructions only till if CX register is not equals to 0 and 0 flag is not high, not high, remember. So that means ZF, the value of ZF should be 0. The status of 0 flag should be low. Okay, so this completes your these instructions. Now in the next lecture we will deal with the next particular topic. Till then, take care.